All right, so we're going to start Unit 4, which is all about moles. So you might be wondering, why are we in a chemistry class and we're talking about moles? Aren't those like furry creatures that dig underground and sometimes look pretty creepy because they're all ugly and or sometimes they're kind of cute depending on what type they are? Or what about those like things on your face or like whatever? Sorry, bell's going. There's actually another definition of the word mole that we use in chemistry, and it's referring to something called Avogadro's number. So Avogadro's number is this really big number. It's this one right here, 6.022 times 10 to the 23rd. I actually have a chemistry teacher friend who has a mole, and she got that number tattooed right next to it. It's pretty awesome. This number is so important because it was discovered not actually by a guy named Avogadro, but he kind of contributed to coming up with this idea, so they named it after him. And this is it's a number. It's a number like any other number. It's kind of like a 12, like a dozen. You know, that number has a name. Other numbers that you might encounter in life also have names, but that's probably the one that you see the most often. What's so special about this number is it is a number that helps relate atoms to mass. So one of the problems we have in chemistry is we have to be able to count atoms sometimes. Like if you're looking at all of our formulas we learned from last unit, we know that sodium and chloride is a 1-to-1 ratio of sodium to chloride atoms. However, we can't really count atoms. That's not possible. There's too many of them. There's so many of them. We just can't do it. So what would be really nice is if we knew how many atoms are in 1 gram of a particular substance. Then we can just use mass to count instead. And the question then is, how do we correlate those two and how do we figure that out? So this is where Avogadro's number comes in. Avogadro's number is defined as the number of carbon atoms, of carbon-12 specifically atoms that are in 12 grams of carbon. And this makes sense and is really helpful because if you look at carbon here, the atomic mass of carbon-12 would be 12. So that means that we can connect the mass, the atomic mass of the periodic table with actual masses that we can really measure, like grams, in real life. And now we can suddenly find the number of moles or the number of atoms in anything. We define this actual number as 1 mole. Okay, so a mole is the word that we use to represent, and it's actually right here. It's the word for Avogadro's number. So dozen is the word that we use for 12. Mole is the word that we use for Avogadro's number for 6.022 times 10 to the 23rd. By the way, 6.022 times 10 to the 23rd is a massive number. It's a good estimate of the number of grains of sand on the entirety of the planet Earth. It is such a huge number that it's like incomprehensible. I'm actually gonna have you watch some videos all about that. But atoms are so tiny, molecules are so tiny that you can have hundreds of moles of something and it's not even an issue. This water bottle is full of water. This is probably about 10 moles of water. So there are way more water molecules inside of this water bottle than there are grains of sand on the entire planet. That's how freaking small a water molecule is. And sometimes we don't always just want to know about the mass of water. We need to know how many molecules there are. And so that's why we use moles. Chemists love them. I love moles. The only thing I love more than a mole is an electron. They're both great. So yeah, we're going to use this all the time. This little part here, I'm just going to cross this out because we're not actually going to worry about that yet. Okay, so the big thing here, the big take home is that 1 mole of something, mass of 1 mole is equal to atomic mass on the periodic table. There's actually, it's really interesting, the mole was, it took a really long time. There's a whole history about how they came up with this number, and I'm going to link you to some videos. It's actually not based off of carbon-12 anymore. It was for a while. I think it was also for a while based off of oxygen-16. It has now been redefined to being 28 grams of silicon 28. So however many silicons are in 28 grams of silicon 28, that is how many, that is what a mole is defined as. So this number actually has many more decimal points. It's like 6.022, blah, 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 times 10 to the 23rd. The times 10 to the 23rd is scientific notation. It just means that there are 23 zeros. Sorry, take that back. You move the decimal place over 23 times. So you end up with an absolutely absurdly massive number. So to help you sort of start to conceptualize this idea, I'm going to show you some videos. These are all on my YouTube channel, and I'm going to make links to them that I would like you to watch. This first one is wonderful. This is my YouTube channel. This is Chemistry Unit 4 playlist. This one is really great. You should absolutely watch this one. It's less than 5 minutes long. It's a TED Ed video. It's super, super delightful. This next one from Numberphile is really also very interesting. I would recommend that one. And then this last one is a Veritasium video. I love Veritasium's videos. They're wonderful and always very, very interesting. This is one from 9 years ago or 7 years ago, where he went to go look at the world's roundest object, and it will relate to a lot of things and measurements and lots of concepts, but those are great. If you would like other introduction, you can also check out these Tyler DeWitt videos. So these two are great introduction to moles, counting atoms, and the difference between a mole and a molecule. They are very different. A mole they come from the same word, it's the same root, but a mole is just a number, whereas a molecule is like the actual thing itself, like a water molecule. You can have a mole of water molecules, but one's a number and one's like the actual molecule itself. So yeah, so those are the videos that I would watch. I also have a comic for you. It's in Teams, and if you go into the files, I'm also going to make a link to this. It's this PDF. This is really fun. There's this guy named Randall Munroe, and he does a webcomic called XKCD that I love. And he also he wrote this book and does this comic called What If? And this is the question: what would happen if you were to gather a mole, the unit of measurement of moles, the small furry creatures, in one place? This is really cool because he takes these like absurd questions and really takes them seriously. And if you read through it, it's disturbing and fascinating to read through that. So that's what I want you all to do to help you understand what a mole is. We're going to go over this obviously in class some more, but that is your assignment right there. So I'm going to let you go, and when we come back for the next set of units, or next set of notes, pardon me, we're going to go through how to calculate the molar mass and how to use, and then how to use that. And that's the whole point of this unit. Super important stuff, and I'll see you next time.